Okay, so what I wanted to do was, not knowing the background of everybody that was going to be at today's call, I would start with some insulation 101. So maybe there are people that focus on interiors of buildings or structural aspects. So I didn't want to not tell you where the on switch was before we dive deep into some of the topics that Anthony will get into in his part of the meeting. So there are some of the things I'm going to cover in the first slides. If you all know this, the good part is I'm going to ask Justin to move fairly quickly through the early slides, but they will be available if you need to refer to them coming up. So Justin, if you could go to the next one, please. All right, so I think those of you that work in buildings, design for them, know that whenever you're going to make an energy efficient building, thermal insulation in the building envelope is really important. So there's one definition from a trade association website of what insulate means. I think the second bullet is more appropriate for architects and specifiers in that you're often limited by the building code in terms of the minimum required levels of thermal insulation or the thermal performance of envelope portions that you deal with. So building code sets the minimum, however you want to go to the highest levels of energy performance, like passive house, is up to you. Those of you, particularly in the residential sector, know that a lot of times the provincial code, the state code, local, it may lag behind the current edition of the model energy code by several years. So that's good to keep in mind. Next, please. All right, so again, we're gonna see some applications in buildings coming up, but if you ever move to a different part of the industry, if you get into commercial industrial, those things can include really high temperature applications. So like a chemical refinery, a power plant might take high temperature insulation for equipment, for reactors and so on. At the other end of the spectrum, you need cryogenic equipment insulation. So liquefied petroleum gas terminals, for example, have some specialized needs. A lot of types of insulation have acoustic benefits. Not all do, but a lot of them do to various extents. Clearly, if you're designing for a commercial building, you need to worry about fire safety. So certain types of insulation can be used as fire blocking, fire safing. Insulation can provide condensation control. You often see that a lot of products will have low perm vapor barriers so you can manage moisture. And then some types of insulation may also be effective air barriers. Not all, some of them are very air permeable, but some are pretty good. Next, please. All right, so here's a pictogram representing a commercial building. This could be, a small office building. It could be a school, could be a hospital or medical building. And again, you may design things that are a lot taller than this, high rises, a little more spread out like a manufacturing plant, but they share some things in common that, the building envelope will be insulated. So roof insulation, wall insulation, foundation, slab, basement, whatever your local code probably requires. And then you'll see some interior applications of insulation. So, where fire safety is important around elevator, shafts like that. You may see acoustic applications around conference rooms, quiet rooms, and you may see some other soundproofing applications inside. But again, a lot of the envelope is going to be driven by code and your climate zone. Next, please. So if you deal with the residential sector, that homes, apartments also have to worry about the thermal integrity of the building envelope. So again, attic, roof, walls, foundation, basements, those all typically have code requirement minimums, and you'll see some interior applications. So again, these are typically acoustical for the most part, but you may see some people using more fireproof insulations in certain areas of a home. One thing to point out that applies to both the commercial and the residential is that in an ideal world, your outdoor temperature would be very close to your indoor, and there wouldn't be a driving force for heat to move in one direction or another. But in reality, the outdoor temperature is higher, lower than your desired indoor temperature. And the greater that temperature difference, the greater the driving force. So the greater the delta T in temperature, the temperature difference, and the bigger the temperature difference, the bigger the driving force there is. I know you folks in Seattle had a heat wave fairly recently. My daughter lives up there. You probably know, if you have a well-insulated house, that can help keep the inside cooler for a while. It's not a magic bullet. Eventually that driving force is going to move heat or cold air where thermodynamics wants it to go. So you can't really stop it completely. You can slow it down and let your HVAC system handle conditioning the indoor air. You probably have seen, if you've been following how crazy the housing market has been, that building materials have been in short supply. Lumber, it was the poster child, but clearly that has impacted other building materials. Insulation, for the most part, was on allocation or sold out in many parts of the country. I think things are stabilizing, but again, this may also cross over into the commercial sector, increased lead times for materials. So just wanted to have that truth in advertising there before Justin moves on to the next slide. All right, fortunately for you in the design community, you've got a lot of different choices of types of insulation. So some of these are going to be familiar to you. The fiber insulations, the rigid foams are very popular for roof and some exterior applications. If you go to your big box store, you'll see flexible foams for like pipe insulation. Spray polyurethane foams kind of dominate the spray foam part of the market right now. And those can be open, closed, or hybrid cell. And then there's a number of other insulation types. So cellular glass, aerogels, perlite, vacuum panels, polyester in some other geographical regions. So a whole bunch of different choices for you. And the bottom bullet really kind of summarizes that you're probably going to pick those based on a whole combination of properties. You may need a certain R per inch for your envelope that you're targeting. You may need something that's highly water resistant, something that has good fire test properties, and some other things that might go into your design choice, like you're building a LEED certified building and you want certain documentation for some of the LEED MR or IEQ credit opportunities. Next, please. So we're starting to get into a little more detail, and maybe something that you may not know about, but typically each type of insulation will have its own ASTM consensus standard or specification. So here are some of the ASTM references for a number of the most popular insulation types used in single family or commercial. There are a whole bunch more of those. ASTM would be glad to sell you as many standards that come out of C16 as you want, but there's definitely one probably for any type of insulation that you would want to use. Let's go to the next one, Justin. And again, if you've never looked at an ASTM specification, if you do buy one or have one in your organization, a lot of times they'll break out by insulation types. So I've got a couple of different ASTM standards for the mineral fiber segment, and the use temperature range often separates different types. So typically you need something, maybe a different composition for a maximum use temp of 450 degrees F versus something going to be used at 1200 degrees F. Other insulation types, and again, this usually can vary depending on the composition of the insulation. I've got the rigid cellular polystyrene standard there. That has some types based on compressive strength and or density. So again, it kind of depends which actual type from each specification may be appropriate for your application. Typically let's go back one, yeah. The higher density products, and this is kind of common sense, but you may not realize it if you look at an EPD, is that they'll typically have higher compressive strength and other properties, but they do require more resources to manufacture. So a higher density, higher thickness product is going to have more resource needs than a thinner product at lighter density. And the last bullet, again, environmental product declarations, we're going to talk a lot about those later. Anthony is. But you need to watch to see if they're broken out by density or density range. They may also have correction factors for other product components like a facing. A good example will be a facing is going to make the most contribution to a very thin product or the lightest density and thinnest product. So it can be rather significant if you look at recycled content contribution across thicknesses, how that can vary depending on the product type. Next, please. All right, so Justin asked Anthony and I to cover some topics that people had questions about or were of significant interest. So I'm going to tee up some of the initial discussion on blowing agents and their importance for some types of insulation. Anthony's going to go into a lot more detail on some aspects, but I think it's important to at least start out with a little bit of intro. Then I'm going to give some caveats for comparing environmental product declarations or EPDs that some of my life cycle practitioner colleagues have passed on to me. So I think those will be good before Anthony gets into his deck. So next one, Justin. All right, so not all types of insulation use a blowing agent. Some do, and of those blowing agents, they may not have a significant global warming potential GWP impact, but some do. So typically you see in the foam plastic insulations, the closed cell types, that the blowing agents can differ. It can depend on the insulation type. Also, a blowing agent can be chosen because it has a low thermal conductivity. So that will improve the product's R per inch as opposed to if just let air fill the cells. So that's why one reason for certain types that manufacturers will use blowing agents. For the most part, expanded polystyrene and polyisoboard, they typically use pentane or other hydrocarbons. Pretty insignificant GWP impact. If you're looking at open cell or hybrid cell spray foams, the water is reacting with the isocyanate in the A side to yield carbon dioxide, so that makes the insulation foam up when parts A and B are combined. And carbon dioxide, by definition, is a GWP of 1. And so an open cell typically is air and CO2, after it sets up and fills the cavity. Different type of insulation, extruded polystyrene in North America. Right now, hydrofluorocarbon blends are used for the majority of products, but there are now low GWP options available because of 2021 regulations that kicked in. And I'll have more on that on the next slide. And Anthony is always also going to talk about that a bit in his deck. The last point is important because when you look at extruded polystyrene and insulation, they typically use carbon dioxide. So again, because of the thermal conductivity of that gas versus some of the HFCs, they get a lower R per inch, but they don't have the constraint that we have in North America that everybody wants an R5 per inch. So it's good to take in mind the regional differences between products. Next, please. All right, the HFC regs in Canada and some US states have kicked in. Most of them took an effect in January 2021, and there's some other ones being considered for other US states. The main types of insulation they've impacted are extruded polystyrene and closed cell spray foam that use these high HFC blowing agents. I'll point out that DuPont Styrofoam and the Owens Corning formula are NGX. Website content show the regulatory status now and future. Anthony's got a screenshot from the Owens Corning site. I'll also point out that I found that Kingspan for their LG XPS product also has some content on the reg status. So I wanted to give Kingspan a shout out that their website already also has that information as well. So what you'll see with these redesigned extruded polystyrene products that meet the 2021 regs, they typically will use a low HFC combined with hydrofluoroolefin, so HFO blend, or it'll be a straight HFO with a co-blowing agent or process additive. The closed cell foams, spray foams, for the most part, they have used HFC 245A. Almost all the manufacturers have offered HFO blown flavors in advance of 2021 regs. Typically, those are Opteon 1100 or Solstice LBA, are the two in most common use. And I will say most of the spray foam folks had an HFO flavor well before the 2021 regs kicked in. There were a few that kind of just made it under the wire, but most of them have offered an HFO flavor if you wanted it for 1 to 4 years now. Finally, if you want to know what the blowing agent is, sometimes that will be revealed in the EPD material content table. Sometimes it'll be in a health product declaration or declare label. You will not find it probably in a GHS compliant safety data sheet. And a lot of times a manufacturer may not even have a safety data sheet because installation is usually an article. So you got to rely on transparency documentation to find that out. The only thing I'll add is, since Justin shared a little bit of my Owens Corning history, I spent a number of years in the analytical lab, and there's no good reason that a manufacturer would keep the blowing agent if it's a blend confidential, because it's a very easy analysis to run if you've got the right instrumentation to figure out what's in a competitor's, a closed cell foam. So I think it just makes the manufacturers feel like they've got all this high-tech technology when really it's a pretty easy analysis to figure it out from a former analytical chemist. So thank you. Let's move on, Justin. All right, I'm going to set the stage for some of the upcoming slides that Anthony's going to cover. I wanted to share a couple slides that my colleagues in the group that I work in shared with me. So we have 3 full-time LCA practitioners in the group I'm in sustainability, and they have done a number of training presentations for people at Owens Corning on EPDs, embodied carbon, that whole thing, and they always have some precautionary notes. So I think it's good to at least point these out and make sure everyone's aware of those. So there are a number of things that are on here that I'll let you read through. I'll emphasize some of the most important ones. Clearly, the product category rules and the functional unit. So if you're trying to compare, say, an insulation product from Europe, which may have different rules, different functional unit than something in North America, you really have to be careful of that. You may need a secret decoder ring to figure how those compare. The scope can be really critical. Obviously, if you've got a product with a high global warming potential blowing agent, and one manufacturer does cradle to gate, but another one says cradle to grave and has other modules where you may see significant emissions over the life of the product, then you can't compare those directly without one looking, unfortunately too much better because you're only comparing certain modules in the EPD. The software can be important. A lot of people, if you're not an LCA practitioner, don't realize this, but usually the software packages may pull from different data sets. So I would not take all the decimal points in an EPD to heart. There is some precision statement you should associate with that. And so all of these can introduce error and just some problems in trying to compare one versus another. That doesn't mean that people aren't comparing EPDs. If it's the only thing you've got, at least it gives you a standardized document you can look at, but you should look at the fine print, hopefully, and figure out what those differences are. So my last slide coming up again is on EPDs. So we can go to the next one, Justin. Okay. So again, I think you all know this if you're in the design community, but they're really important in the green building rating systems. LEED, V4 and 4.1 have really driven the push for manufacturers to publish environmental product declarations. The LEED V4.1 has an additional MR credit for some of the optimization possibilities, including optimized reduced embodied carbon. So look for those. And I don't want to take too much more time because I know Anthony's got a lot to get to. So I'm going to go ahead and punt right now and let Anthony take it over.